Alright guys, so we're going to look at the next step up in differentiating now. So what happens when we have a function of a function? Now this rule gets a lot of different names. We call it function of a function rule, or a chain rule, or it's got a few others. I usually refer to it as the chain rule. It's written out like this. So dy dx equals dy du times du dx. It sounds really complicated. What it means is actually really fairly simple. What you can see here in this first example, we've got y equals 3x squared plus x plus 1 all to the power of 4. So what we're saying is that y equals u to the power of 4. So we have some function u that has the power of 4, but that u is itself a function of x. So we can't just bring down the 4 and take 1 off the power, because it's not taking into account the fact that we actually have this function 3x squared plus x plus 1. And so the formal way of setting this out is to write let y equal u to the power of 4 and that u equals 3x squared plus x plus 1. So then what we say is that dy du, so if we differentiate y with respect to u, we get 4u to the power of 3. But we also need to differentiate u with respect to x. And if I do that, then I get 6x plus 1. And so then, to find the derivative of y with respect to x, we have to multiply dy over du by du over dx, remembering to substitute back in 3x squared plus x plus 1 for u. This is the formal way of setting this stuff out. Piece of advice, don't do that. I'll show it to you so that if you see it, you know what's going on. But the way to differentiate this couldn't be simpler. The first thing you do is differentiate as if the bit in the brackets was just an x. If you had x to the power of 4, you would bring down 4, you would write the x, so we're just going to keep our brackets. Oops, sorry. You would take 1 off the power. And then you go, well, hang on a minute, what happens when I differentiate what's in the brackets? Well, if I differentiate 3x squared plus x plus 1, I get 6x plus 1. Isn't that easier? That's it. Now, you're welcome to try expanding that out, but I wouldn't, because we tend to screw up cubics and it's really not going to achieve anything if you do. So the derivative of y, whoops, we didn't write that either. Sorry, guys. Derivative of y is 4 outside of 3x squared plus x plus 1 all cubed times 6x plus 1. That's the chain rule. So let's have another go. So if y is equal to 2x cubed plus 5 all to the power of 7, then when we differentiate y with respect to x, we get 7, bring the power down, keep your brackets just as they are, take 1 off your power, and then multiply it by the derivative of what's inside the brackets, which would be 6x squared. Now this one we can tidy up because we've just got that bracket with 6x squared and we've got a 7 at the front. So I would multiply them and then keep my brackets. So while the formal definition and the formal setting out does look complicated, the process itself really is quite simple. Now if we get one where we have a function of x inside a square root sign, the thing you've got to remember is that the square root can be written as a power. And what power is it? Who remembers that one? So rewrite this with your power, because you can differentiate anything that has a power. So this is x squared plus 2x all to the power of a half. Okay, if you forgot that, you need to go back and remember it, because it is in your exams all the time. Alright, so then looking at that, when we're going to differentiate that, we get y dash is equal to, bring your power down, keep the things inside your brackets, take 1 off your power. So if I take 1 off the power, I get negative a half. Then multiply all of this by what's inside your brackets. So the derivative of what's inside the brackets is 2x plus 2. Okay, so a few tricks here. You've got a half, but then we've got this factor 2x plus 2, which has a common factor of 2. So if I take out that common factor, I can multiply that by the half, and all that stuff goes away, leaving me with x plus 1. And then I've got this bracket x squared plus 2x all to the power of minus a half. Now, don't let me down, guys. What does a negative power mean? Negative power means that that is going to end up in the denominator. So we're going to keep our x plus 1 in the numerator, and in the denominator we are going to have x squared plus 2x. What does the half mean? Well, we just talked about that. It means it's the square root, and that's the derivative. So that's what you need for exercise 8.8. Do as much as you need. Make sure you are comfortable. Don't skip over it. If you have to keep checking how they got the answer, then you need to go back and practice some more. Good luck, and I'll see you in class.